Hi, I'm going to take a moment to just briefly talk about break even one more time. And I wanted to go over a question that you're going to find in your homework assignment, which relates to break even. Okay. And the question here is that Dr. Gulakowicz is an orthodontist. She estimates that adding two new chairs will increase her fixed cost by $153,000, including an annual equivalent cost of capital investment and salary of one more technician. Each new patient is expected to bring in $2,970 per year in additional revenue, with variable costs estimated at $1,000 per patient. The two new chairs will allow the doctor to expand her practice by as many as 215 patients annually. How many patients would have to be added for the new process to break even? Okay, so this is a typical break even question. And my solution for this here is going to be 78. Okay, now let's go about figuring out how to do this. Now, keep in mind, if you get a question like this, you're looking at what point do your total costs equal your total revenue. Okay, and I'm going to do this on a spreadsheet. I'm going to do it two ways. I'm going to do it the algebraic approach, and then I'm going to use solver as well. Okay, so let me go into this spreadsheet right here. Okay. And what I have here are our fixed costs, which are given to us in the question as 153,000. Our variable cost was $1,000 per patient, and the doctor charges each patient 2,970 for the procedure, whatever the procedure here is going to be. Okay. Now, for all break-even questions of this type, we're interested in our break-even point. Our break-even point, BEP, will be at the point where your total cost equal total revenue. Okay. And our total cost here is going to be a function of what's our fixed cost plus variable cost. Okay. And our total revenue equals the price that they're charging for the procedure multiplied by our total volume of patients, however many people we anticipate having. Okay. So I need our volume, and I'm going to give that the letter Q. Okay. Now, this formula we have here for the total cost, I'm going to simplify it further and say total cost equals our fixed cost, F, plus our variable cost. I'm going to give the variable cost a little letter C, multiplied by the volume of patients, which is going to be Q. Okay. And our total revenue here, uh, one moment here. This is small letter C, capital Q. Okay. Our total revenue can be simplified to TR equals the price, small letter p, multiplied by Q, which is the volume of patients that we have. Okay. So at break even, TC should equal TR. Okay. So we have our fixed cost, we have our variable cost, we have our price. The only thing that's lacking is what's the volume, what's the number of patients that we're going to have at break even. Okay. So let's go ahead and figure that out. And let's start off with the algebraic approach. Okay. Now the algebraic approach, need to change this one more time. PQ. I don't know, it's not changing for me. Small letter P, capital Q. Okay, so starting with the algebraic approach. With the algebraic approach, I'm going to say my total cost, which is a fixed cost of 153,123, plus my variable cost, which is $1,000 per patient, multiplied by the number of patients. And I don't know how many patients are going to be, so I'll just leave that as a Q. At break even, that should equal our total revenue. Okay. Our price here was 2,970 multiplied by the volume. We don't know what that is, so I'll just leave it as a Q. And I'm going to simplify this. Okay. And I'm going to simplify this by bringing the like terms together over here and saying that this will be 2,970 Q minus 1,000 Q should equal, this should equal 153,000. Okay. And if we simplify this further, we're going to have 2970 minus 1,000. That's going to be 1970Q equals 153123. Okay. And as a final step, if we divide both sides by 1970, we're going to have Q equals, this will be 153123 divided by 1970. And so our solution will be Q equals to 77.6766. And since these are human beings, I'm going to round this off and say we're going to be at break even at 78 patients. Okay. So that's algebraic approach. Just basically set your total cost equal to your total revenue. Okay. Now let's do the same thing, but now let's try and use Solver to answer the same question here. I'm going to open a new tab and do it here. Okay. So again, if I'm to use Solver, make sure you have Solver on your Excel page. Solver will typically be found under data, and you should be able to see Solver over here. Now, if you don't have Solver, you can go to File, go to More, Options, and there should be an add-in option here. And when you click on that, it should bring your analysis tool pack. And you click on that analysis tool pack, click on Go, and look for Solver. Click on that and say OK, and that should bring Solver into your screen. Okay. So now I have Solver here, and Solver is going to walk me through 5 steps to be able to arrive at the solution to this. But before I go into Solver, I need to put these formulas together, because the formulas I had was total cost equals fixed cost plus variable cost. Okay, so I'm going to need to have somewhere on my table here, somewhere where I capture the total variable cost, because I only have variable cost for one patient, but I don't know what my total variable cost is. So I'm going to have total variable cost over here. Okay, keep in mind that the variable cost is the cost for one patient, C, multiplied by all the total number of patients at break even. Okay, so that's what I'm going to do here. I'm going to multiply C, which is a variable cost, by the volume, which we don't know. Okay, and I'll take out those question marks because that's not a number. Okay, so now I have a formula for that. The last thing that I'm going to add here is what about a formula for total revenue? And this would be a function of the price multiplied by the total volume. Okay. And let me put here some formula text to guide you. Okay. So now I'm ready to go into Solver and have Solver figure out the one missing variable here, which is what's my total volume. Okay. So let's go into Data, Solver, and then let's work our way down. For my objective cell here, I'm going to take any one of these. I'm going to say, let's set this equal to my total variable cost. Okay. And I'm going to, oh, before I go into there, actually, I have to, let me pause for a moment. Let me pause for a moment because I missed one last step. We need to have our total cost, not just the total variable cost, but our total cost, right? So our total cost is a function of your fixed cost plus our total variable cost. Okay. So these last two cells here have to end up being equal at break even. So I want to make sure that whatever values I get here should be the same. Okay. All right. So now let's go back into Solver and let's try and solve this. So Data, Solver, And I'm going to set my objective function cell equal to my total cost. Okay. That's step one. And since I'm talking about cost, we always want to minimize cost. You don't want to maximize cost. You want your cost to be as low as possible. So I'm going to click on the min function by changing the variable cell. So this is where you have your unknown, what I have highlighted in yellow here. I'm just going to click on this cell and say, hey, this is where I want a solution. Tell me how many patients we need to have at break even. Subject to, I'm going to add just one constraint. I'm going to say that at break even, total revenue should equal total cost. Okay. And the last thing that I'll do is put this equal to a simplex LP solving method because we're assuming that it's a linear relationship. So I want the solver to assume a linear relationship here, and then I'll go ahead and solve. Okay. It's going to give me my solutions, maybe a bit too many decimal points. You can always reduce the decimal points as much as you want. Over here, let me reduce this. Okay. So keep in mind my volume here is the number of patients, and all these others are going to be cost. So these are dollars. Okay. So at break even, we're going to have about 78 patients, and our total revenue at break even is going to be $230,665. And our total cost will be the same at break even because those two cost curves intersect. Okay. So that's the two methods that I typically would test you on. Um, Try and get comfortable with them. I think we might do something like this again before the midterm or before your test one in class, just to make sure you're comfortable doing this. But basically, that's how you go about doing a break-even analysis. All right, let me stop here. Thank you.